Hello everybody. So we're going to talk about infinite limits. That is, we're answering the question this time of what happens to functions when we do have some of those non-removable discontinuities, and more specifically, the kind of functions that we know are the ones that have vertical asymptotes. These are functions that increase or decrease without bound as x approaches some fixed value. So let's consider a couple of the following limits right here. We talked about one-sided limits, and here's a one-sided limit that asks what happens to the limit as x approaches 3 from the left-hand side of the quantity 1 over x minus 3. And we can imagine a few values of x just to try them out, uh, talking about values of x that approach 3 from something less than 3. We mean things like what happens at 2.9, or what happens at x equals 2.99, and values that get even closer as x approaches 3 from the left-hand side of 3. So let's look at that. Well, of course, if we try 2.9, of course, that means we're dividing by 1 over 2.9 minus 3, that's 1 over 0.1. And if you work that out, you know that is equal to 10. We try it with a 1 point, we try it with 2.99 minus 3, that's 0.01 is the difference. We go to 100. And you can see the pattern that's happening right now as x gets very, very close to 3 from the left. Right? We're getting values that are approaching 1,000. Now, the only problem right here, of course, you might have noticed, was that these values are negative, right? If we say 2.9 or 2.99 or 2.99, so these values are actually getting bigger in the negative direction, right? And so what's going to happen as x gets very, very close to 3, right? These values are just going to keep going up. What's the limit? Well, there really is no ending limit. We say it increases without bound, and this time it's increasing in the negative direction. We call that direction negative infinity. We're saying that the function tends to negative infinity as x approaches 3 from the left, right? So this is increasing without bound in the negative direction. This isn't saying that the actual value exists. It's really just to say that as x approaches 3, it increases without bound in the negative direction. Of course, we can say a very similar thing as x approaches 3 from the right of our function right here, and these are values such as 3.1 and 3.01 and 3.001 and so on. And we can see the same pattern is going to happen as x gets closer and closer. Our value 1 over x minus 3 approaches 1 over 0.01. That's 100. As we approach 0.0010, 0.001 here, our y value goes towards 1,000. And as you follow the pattern right here, as we did before, it's tending towards positive infinity. That is, this function is increasing without bound in the positive direction. So we say this limit tends to positive infinity. This limit right up here tends to negative infinity. So what does that mean for us overall? Well, if we look at this particular function, we're saying that as we approached 3 from the left-hand side, the y value was tending towards negative infinity, beyond. And as we were approaching from the right-hand side, y was approaching positive infinity. So in this particular case, we're saying, well, what would be the limit as x approaches 3 overall? Well, in this particular case, this is the two-sided limit. And what we would have to say at this point is that this two-sided limit could not exist. Why would that be? Well, exactly. There's actually two reasons. One is that both sides have a different behavior, right? As x goes from the left, y goes in the negative direction as x goes from the right, y goes towards positive infinity. So they're approaching two different values, so that limit doesn't exist. The other reason is that it's unbounded behavior. So really, when we're looking at these limits, that's one thing that we have to keep in mind.